Greetings! Today I'm going to be showing you an online experiment that is free to download that you guys can use that I have developed here for use in my online studies in my lab. Before we get going, I just want to give a big thanks to Dr. Matt Pastizzo, who's a colleague of mine in my department, who was the original author of this experimental code. He passed it on to me, and I modified it quite a bit to turn it into what you see here today. But nonetheless, the majority of the structure of the code that exists here was Matt's doing originally. So Matt really got this thing started. I've modified it and sort of put it in a general use form that you guys can all get access to. So we'll be walking through the code today. But I just want to say, you know, this experimental code, you can download it. It's free. You can use it to run your own experiments. Just please leave the original credits. So leave Matt's name and leave my name. You can add your own name. That's fine. But just leave our names so that if you eventually pass your code on to somebody else, they can just see where it originated from. And, you know, as academics, we should be giving credit where credit is due. So that's my only ask of you guys. And as you can see here, this experiment requires access to HTML, JavaScript, PHP, and I recommend SQL as well. We will be going through all of these in turn as we walk through the experiment today. So let's get going. So this is exactly what a subject would see when they come to your experimental page. After they click begin, the screen will maximize, and then they'll be presented with the instructions, the welcome screen, and they'll be asked to basically sign their name as a digital signature. Now all of this is modifiable, of course, but I'm just going to enter my name here and participate in my own study. After the instruction screen, in the experiment as it is right now, this is just a very basic production effect experiment. If you're not familiar with the production effect, it's a really basic phenomenon in human memory, and I study it a lot in my lab. Basically, what's going to happen is we're going to show a series of words to subjects, and we want the subjects to remember those words, and then later on there's a recognition test. So it's a very simple two-phase experiment. And in this experiment, some words appear in yellow and some are in blue. And in this case, when a word appears in yellow, subjects are supposed to say it aloud, and when it's in blue, they're supposed to read it silently. And that's pretty much all there is to the study phase. So there's only a few items here. So subjects would say still. Subjects would just read owner without saying anything. They would just read surface, series, and so on. I'll let this study phase sort of run its course. I have it set to only a few trials in the study phase and a few at tests so that we can go through this fairly quickly. But I just want to first show you guys the experiment, and then we'll take a look at the code that you can download, and we can walk through how the code works and how you would modify it for your purposes. So after the study phase ends, there was that little screen telling them it was over, next some instructions for the memory test, and then they go ahead and they see words that they might have studied and some words that are new. And I was only half paying attention, so I'm going to try and do this test. But probably my performance here is pretty bad. So let's see, error. Not too sure about many of these, again, because I was talking for the study phase here. And there we go, we've completed the test. One last component of this experiment is a sort of survey at the end. And, you know, any of these components that you may need or may not need, you can just pull out and get rid of. I like to have a survey at the end of my online experiments, especially because usually when I have research assistants run subjects in the lab, we have a protocol where after subjects have finished performing the experiment, we talk to them a little and ask them a few questions to make sure they were doing the experiment correctly. I mean, you would also have a research assistant walking the subject through the different phases of the experiment. So I would usually have an RA talk to subjects and walk them through the test instructions before they actually start writing the test. For an online study, you can't really do that. So the best I think you can do is just verify after the fact that people were doing things correctly. So what was the color that you were reading aloud? I was supposed to be reading the yellow color aloud. So if I were a subject, presumably I would type in yellow. And then we have questions about, did they not read any items aloud, or did they accidentally read any silent items aloud? And then I like to have a free-form response box where subjects can basically type in anything else that they want to tell us about the experiment. And this is all just basically going to get logged in the data file and help us look at subjects' data to make sure that they were performing things correctly, they weren't making too many mistakes, and we can make decisions about dropping data if they were making mistakes. Anyway, after the responses are submitted, the screen will de-maximize, as you see there, and then you'll get an option to give subjects some debriefing information. So tell them a little bit about what your study was about, thank them, give them contact information in case they need to reach out to you afterwards. And that's it. A pretty simple setup. So let's take a look at the code, and I will walk you through how this experiment works code-wise and what you can do with it. So here are all the files that you will get if you download the code. We're going to walk through each of these very quickly. I mean, some of them we'll spend more time on than others, but here are the main PHP and HTML files, which we'll go through. In the files folder, this is our stimulus file. So I've just called it 360 words. If I open it up, you'll see it's basically just a CSV file with one column and a whole bunch of words. 360 words, in fact. How about that? A few other files here. These are basically just dependencies. exp.css. This is a CSS style sheet, which basically contains all the formatting information for our experiment. So the reason our experiment was on a black background and the font was the size that it was and so on. If you're familiar with HTML and CSS programming, you can go in and you can change the style and the look of the experiment here. We're not really going to be talking about that much today. Jquery is a library that is used to allow you to use JavaScript to manipulate all sorts of things in HTML files. So this is just another dependency library that we're using, and we'll see it. We'll see functions from jQuery being called in our main experimental file, and this is our main experimental JavaScript file. We'll look at it in just a moment. In fact, this is where the majority of the code for the experiment actually is. Everything that runs locally for the user is here. So this is where you'll find experimental flow and variables and the consent form and the debriefing form, and everything about how the experiment works can be found in here. So these other files are basically files that are going to live on your server. And these are files that allow the JavaScript file that we saw to interact with the server. And for instance, load the words that can be found in this CSV file. So when we look at this load words file, all it's going to do is open that CSV file, grab all the words, and send it back to the JavaScript experiment. The log data files here are the PHP files that the JavaScript's going to call when it wants to log data to the server. And I actually have two ways of logging data in this code for you guys. One way, the recommended way, is to log the data in a secured SQL database. Alternatively, if you can't get that working, there is a method for logging data directly to text files. I don't fully recommend it because it's not completely safe and secure, and people could get access to your files if they, knew what to look for. But nonetheless, it is here, and it is, up to you guys to decide how you want to use these files. So I take no responsibility for how this experimental code ultimately gets used. A little disclaimer here: if any of these files compromise the safety of your network, that is your responsibility to sort out. The files I have here, I'm pretty sure are not going to compromise the security of your network, but I would definitely check with your IT department before you put PHP files on your university's network. Make sure they have okayed the files. Make sure the files aren't going to introduce any security holes. Again, I don't think they will, but it's always best to check these things because you don't want to be the lab that caused your university to get hacked somehow. And then we have two helper files here, which I use to give RAs access to the list of subjects who have participated. And this is just two little files that let them easily and quickly see a list of who's participated. And then the RAs in my lab are usually doling out the bonus credits. So this is how they quickly get that information. Okay, so let's actually step through these files together. The first file we're going to look at is the index.html file. And actually, before I open this, I should say that because this experiment depends on PHP, you cannot run this experiment locally and test it. It's not going to work. You need to be running this on a server that has PHP. So for my purposes, here are the files stored locally on my computer, and here are the files on my university server in the web space that I've been assigned. So whenever I edit files in one of my experiments as I'm developing it, before I can test it, I have to drag it over and upload it to the university server. And then in my web browser, actually, I have to navigate to my web space and test it out there. So you can't run this experiment locally. You do have to upload it. I mean, you could access the JavaScript locally, but none of these PHP files will work. And because one of the most important files loads the stimuli that you're going to use in your experiment, you can't really test your experiment locally. So you do need access to a web space that has PHP if you want to play around with this experimental code. Okay, but the first file that we're going to look at is the index.html file. This is a very bare bones file. It makes reference to the experiment CSS Style Sheet. It makes reference to the Jquery library that we need, and it makes reference to the experiment JS file, which is the main experimental JavaScript file that we're going to be using in this experiment here. Other than that, it just has a basic body that when it loads, it calls a function called setScene to ready. And other than that, that's basically all it does. So all the action is going to be in our experimental JS file. So let's see what happens when we call setScene ready. All right, so this is the main experimental JavaScript file. We've seen this header already at the beginning of today's video when I talked about, where the script came from. But let's go looking for that setScene function. Now, if we start scrolling down in the code, the first thing we encounter is an area where you can specify variables or parameters that are going to be used later in the experiment. I'm not going to go through these at the moment. We're going to come back to this. I want to find that setScene function and basically follow the experimental flow through the code. The next thing we'll find after the experimental parameters is a series of screens. So these are basically just string variables, like the ready string, the welcome string. But if you actually look at the strings that are in those variables, it's basically HTML code. So if you're familiar with HTML coding, you can spot familiar HTML tags. Again, today's video is not going to teach you how to code in HTML or teach you how to code in JavaScript. I'm assuming a base level of knowledge. If you cannot follow what is written in these string variables, then it suggests that you're going to have to go and either find somebody who's fluent in HTML and JavaScript or do a little bit of reading or run through some YouTube tutorials yourself to get caught up. So today is really just me showing you the script. It's basically up to you guys to have the fluency that you need in order to modify it. But I will tell you exactly where you can go to modify things and give you a layout of the script. By the way, here's that ready variable. Remember that in the index, we called setScene and we passed a variable called ready to it. Well, if we go back and look at our JavaScript here, ready is a small bit of HTML code that basically sets up a button that says begin experiment. And when we click it, it calls the begin experiment function. So let's find that setScene function, see what it does, and then we'll see what begin experiment is doing. Okay, so we keep scrolling down. There's a lot of screens, so they all have their own HTML code variable. There's a study and a test variable. We'll come back to that. There's a begin experiment function, but let's just skip that for a moment. And here is setScene. setScene is the main function in the code that basically moves the experiment from scene to scene to scene. So a scene could be a welcome or an instruction screen. It could be instructions before a test. It could be a debriefing scene. It could also be a study scene. So a study scene is basically just showing a stimulus, and we have some special code that will loop that through a series of stimuli. But nonetheless, the study phase is a scene. The test phase is a scene. So what setScene does is it takes the name of a variable. So if you said setScene, and then you put in quotations, ready, then what setScene would do is it would look for a variable called ready. Do note that you don't call setScene and directly pass the variable ready. Instead, you put ready in quotations, and setScene will do the work to look for a variable called that. So if you wanted to set the scene to the end of the test phase, you would call setScene, and then in quotation marks, you would add testEnd. Why are we passing the variables in quotations rather than just passing the variables themselves? Well, it's because there's a few special cases that we want to do extra things with, and we want the variable names so that we can quickly check to see if we're in one of those special cases, like a study phase or a test phase or the debriefing. The rest of the action setScene basically just sets the main contents of the main area of the screen to contain the variable that you've passed along. So in this case, the ready variable. And then it scrolls to the top to make sure we're at the top of the screen. So if we go back to our experiment, the first thing we saw when the experiment began was this begin button. And where this begin button came from is this function here. The body of the page loaded, it called setScene, which loaded up the ready variable. And if we look up to the ready variable, we see that all it contains is a begin experiment button. So this is where that begin experiment button came from. Once you understand that, once you understand sort of what setScene does and how the first button appears on the screen, the rest of the experiment and the flow of the experiment is going to be a lot easier to follow. So when this button is pressed, we call a function called begin experiment. Let's see what happens there. In begin experiment, we first maximize the screen by calling a function called maxScreen. And so you can see maxScreen is right here. It maximizes the screen. We clear the scene, so we clear what's on the screen, so subjects now see nothing. And then we call this JavaScript function called setTimeout, and we say, in 250 milliseconds, call setScene again, and this time have a welcome screen. So we could have directly called setScene and have the welcome screen come up. All this setTimeout function is doing is saying, rather than doing that immediately, just have a 250 millisecond gap. So if we go back to our experiment and we click the begin experiment button, there's a brief pause, and then the welcome screen will appear. And now we see all this. We see a welcome message and a spot to sign our names and a consent button. And if you look up your instruction screens, you'll find there is a welcome variable, and it contains exactly what we saw on the screen, a header that says welcome to the experiment, details about consent. And then there's an input text box called consent name. There's also an area, by the way, where we can output an error message to subjects. Again, I won't go through all the details of precisely how this works. If you're not familiar with JavaScript, you're going to have to do a bit of reading on your own. But if we do type in an invalid name, so if I only gave my first name and I clicked agree to participate, I'd get a little error message that would appear. So this is just something slightly more advanced I added into the script so that we can give feedback to subjects dynamically in the web page. What we're doing, by the way, the way we're detecting if there's a valid signature is that whatever name is entered has to have at least one space, and the two words that are entered, the two names, have to be at least 2 characters long each. So that would be a valid name. That would not. And that would not. And that would not. So has to be 2 words, has to have a space. That's the basic check that I'm doing to make sure that people are actually signing their names. So that's it's called an error wrapper, and it wraps around an error text area where you can insert your own error messages if you like. And then we have the button at the bottom that tries to save the consent. And if saving the consent is successful, then it sets the scene to study instructions. So setScene is this variable that's stepping you from one phase of the experiment to the next. And you'll see that every scene we set at some point has a button or a time where it will set the scene to the next part of the experiment. The only time we stop setting the scene to another part of the experiment is on the debriefing form. If we look at the debriefing form, so we should be able to sort of read the code now and see, okay, this is going to be the debriefing form. It's just a big thank you message. And there's nowhere in this form that it sets the scene to anything else. So this is the terminal end of the experiment where now there's nothing left to do. Let's go back to the consent form a little bit and carry forward following what the experiment is doing. So first it tries to save the consent, and then we'll look at study instructions. So what happens in the save consent function? Well, let's scroll down and see. We're going to pass a series of functions that we'll come back and see. You'll see there's a section for study phase functions, and we'll come back and take a quick look at those. There's test phase functions. We'll come back and take a quick look at those. There's some data logging functions, and we're definitely going to come back and take a look at those. And here is the save consent function. This function uses Jquery to first make sure that the error wrapper is totally cleared, and then it checks the consent name. So it does my little check of making sure there's a space, making sure there's at least 2 letters. I mean, I actually check to see if there's 5 characters total. You know, whatever. You can get more sophisticated if you really want to scrutinize subjects. Make sure they're typing in valid names. If there is an error, it types the error out to them, makes that error visible. Otherwise, it logs their consent ID. And the way it logs the consent ID is it posts data to a PHP file on your server. So let's take a look at how it's actually sending data to the server. So there's this function called post data. And I will tell you right now that what post data is doing is you give it a file name of a file that's on your server that you want to send data to. You give it data that you want to send. In this case, we're grabbing the subject's name that was typed into the consent name field. And you optionally can include a callback function. And so we'll figure out what this callback function does in a moment. But for now, let's focus on the fact that we're sending data to a file, and the data that we're sending is right here. So in this case, just the subject's name. If you are curious to see the guts of this function, you can find it down here in the data logging area. So you can see that we're posting data to a URL, and we have an optional return function. And there's this more complex data request function that's doing all the work. I leave that to you to dissect if you're advanced enough to follow it and you're so curious, but you don't really need to know exactly how this is working in order to actually use this code. Okay, so what file are we posting the subject's name to? We have log subject file. If we scroll up to the top, in our parameters area, this is where we're going to find some file names. So log subject.php, this is where we're logging the subject's information. So if you go back to the list of files that I've given you, there's a function called log subject. So let's take a look at that. So this is the subject logging PHP file. When data is sent to this file, it takes that data and it logs it into an SQL database. In this case, a Postgres database. If you're not familiar what Postgres is, you can ask your IT department and they might be able to help you set it up, or they might already have it set up. Again, you know, if you really are unsure what it is, you're going to have to do your own homework and figuring it out and watching a few YouTube tutorials. But it is a very common type of SQL database. So first thing that happens in this log subject file is it connects to the database. We'll take a look at that in a moment. We set up a default value to log, which is no name, and then we try to see if we have been sent new data. And if we go back to our JavaScript here for a second, and we look at the post data function, we pass this data along to data request, and what the data request does is eventually it sends that information and it calls it new data to the receiving file. So new data is whatever we've sent from our JavaScript to the server. So if we can find something, then that becomes our subject name because this is the logging the subject name file. Then what we do is we're setting up a database query to insert our subject name into our database. And our database is called subject underscore, and then our experiment ID. That's what this little section here is doing. Our experiment ID, by the way, is specified in a file called experiment info. And this is a file that all the data saving files that I've given you reference. So in our case, The database that we're going to be looking for, the table I should say, in the database that we're going to be looking for is subject_exp_demo. If you change your experiment ID to be called my experiment, then you would need a table in your database called my experiment. So whatever name you put here is what you should use in the tables for the database that you end up setting up. So again, we're going to have subject underscore and then our experiment name. As you'll see when we look at log data, there's also going to be a data underscore experiment name. The reason there's two separate tables, by the way, or at least the reason I did this, is because we need to log subject names to know who to give participation credits to at our institution. But we don't want to have subject names logged with the data itself, right? We want to have subject numbers with the data itself. So we actually maintain two separate lists. The subject list, the subject table, is going to contain just a list of subjects who've participated and dates that they participated on. The data table is going to contain all the data from the various subjects. And so after we have actually set up our query to log the subject's name, and we've called it, so pgquery calls the Postgres query function to save our data, and then we close our connection. There's a bit of extra code down here. It's actually very tiny. There's more comments than code, but it takes the subject's name and it transforms it into a number. So there's various different ways you could do this. I'm using a function called MD5, which basically encodes the subject's name into a random or a seemingly random string of letters and numbers. So from an RA's perspective, if they're looking at your data, they're not going to be able to look at the subject number and know who it refers to at all. It will just look random to them, and that's sufficient confidentiality for us. However, the reason that I'm using the MD5 function is because it is possible, if you want, to look subjects up later on. So if a particular subject says they want their data removed from the study, I can take the subject's name as listed in the subject file, run it through the MD5 function, and get their subject ID, and I can then go in the data file and delete their data. Also, if you want to run studies that take place on multiple days, or where a subject runs in your experiment at the beginning and the end of the semester, you want to be assigning them the same subject number every time they come back to your experiment. The MD5 function is deterministic. So if somebody types in the same name on two different dates, then they will get the same ID. And also, if somebody happens to type in their middle name the second time they come in, they're going to get a different subject ID number. But you could go back in and say, okay, well, Joe Smith at time 1, Joe Smith run through the MD5 function gives this subject ID code. Joe Daniel Smith gives this subject ID code. So I know that this is Joe Smith coming back a second time around. You can spot in the data file, and you can figure out when Joe Smith came back. So using a predictable deterministic function like this to produce subject numbers is something I would probably recommend. There is another option that I've left in here called crypt. This actually produces a different unique number from a subject's name every single time they come to the experiment, and it's not possible to recover the subject's name or figure out who it was based on the subject ID code. So if you do want complete anonymity and you have no need to ever look up and figure out whose data belonged to who, then this is a function you would use. Otherwise, MD5 is a great way to anonymize your data so that research assistants and even you can't really tell whose data belongs to who unless you go through a few steps to really try and track it down. So that's what this MD5 is. So what's happening here in the code is that we are basically returning this subject ID code to the JavaScript. That's what the echo MD5 is doing. So let's go and see that in action. Okay, so looking at our post data function, we sent the data to the logsubjects.php file. We sent the subject's name, and we have this callback function called saveSubjectID. This function is called when the log subject file sends something back to the JavaScript. That's what this callback function is. So this is an optional function. As you'll see, when we actually just log trial data to the server, we're not expecting anything back, so we don't even have a callback function. But in this case, we sent the subject's name, and the server is sending us a subject ID number that we're going to use in this experiment. So let's go see how it deals with that in the save subject ID function. So I believe if we scroll up, just above save consent, you'll find save subject ID, and it takes one variable, and all it does is it assigns whatever it receives to a variable called subj ID. And this is the global variable that we are using as our subject's ID number. This variable is defined at the very beginning of the experiment up here, and its default value is no ID. So if somehow subjects get into the experiment and they didn't run through the save consent section of your experiment, if you skip the consent form, then they're going to have no ID. So the save consent, the interaction between the log subject PHP file and your JavaScript, is how you send a subject's name to be logged and then receive a subject ID code in response. And then it's up to you to save it in the global variable that you will be using when you log your data. Okay, before we leave the log subject file, there were a few other things here I just want to point out. It calls a file called dbconnect, and if we look at that, this is a file where we are connecting to our Postgres database. Now, I've taken all my login information out here, so you're going to have to populate this with parameters that you receive from your IT department or that you set up yourself if you're very, fluent and capable in setting up SQL stuff. You can see that here we're referencing the experiment info file, which I've already told you is where we have the name of our experiment, and this will determine the tables we expect to find in our database. But all this PHP file does generally is it logs into your database and it readies a variable called con, which you can then use to send information to the database. So if we look more closely, after we set up our query to send the information into the database, we use the con variable, which was set up in dbconnect, and we used the query variable, which we just set up right here. And so that's basically everything that's happening in your log subject file. I will also give you a quick little look at the experimental demos subject table in my own Postgres database. You can see I just have some dummy names inserted here as I was testing logging in on various occasions. You'll note that I actually have two variables in this table. The first is necessary, called subj, and it's the variable that's actually expected in your PHP file here. This is where you're trying to log your subject ID code. Another variable that I've set up is one called Datetime, and this is a variable that fills in automatically. So whenever you log a subject name, the SQL database will automatically timestamp it so you know exactly when it came in. How I set this up is pretty simple. It's just a column that takes in a timestamp with time zone. And if we go into the column properties themselves, you can see the datetime column has a default value of now, the function you can call in SQL, and that basically just grabs the current date and time. So that's all that's happening here. We're logging the subject name, and automatically SQL is adding a date and time stamp. So if you set things up in Postgres, you can use something similar, and that will allow you to store not only who participated, but exactly when. This date and timestamp, by the way, is a little more crucial when it comes to logging your data. And so you can see I have a subject experiment demo table, and this is where I'm logging a list of who's participated in my experiment. And I have a data experiment demo table. And this is where I log all my data. And we haven't gotten to this part in the script yet, but what you will see is I have the same date and time column, and that's set up in the exact same way with the default value of now. Rather than logging subject names, we're now logging data. And you can see here is a subject's ID code. I told you it was a random list of numbers and letters, right? You're never going to figure out who that was based on the letters and numbers, but that's great. We've anonymized the data. This is a little preview of what we're going to see very soon, but this is basically just CSV data. It is data separated by commas. So we have subject ID code, we have phase of the experiment, we have current trials, 0, 1, 2, 3, 4, 5, etc. We have the stimulus number that's being loaded, so the 13th word from the 360 words. We have the word itself. We have was it allowed or silent, as in this experiment, we have allowed and silent conditions. We have information about timing. And this is actually some old data that I was logging. I've changed some of the parameters since, but just seeing the structure is what I wanted to show to you guys. Okay, returning to our main experimental flow, we have called save consent. Save consent successfully sent information to the subject logging PHP file. We got a subject ID in return and we saved it. What happens next? Well, to understand the flow of the experiment, again, we've got to come back to our various scenes. So where were we? We tried to save the consent form, and if that worked, then we set the scene to study instructions. Here are the study instructions. These are the instructions that tell subjects that they're going to be reading some words aloud and some words silently. Notice that the instructions are actually inserting the colors dynamically. And you may wonder, why didn't I just hard code the colors? Why didn't I just have, figure out the hex code for blue and the hex code for yellow and hard code them in? And the reason is, and one of the benefits of me sort of showing you this instruction screen is that you can be manipulating and randomizing things behind the scenes and it's seamless to subjects. So the reason that I don't hard code the color instructions in here is because I have a variable up here that's setting up the two colors I'm going to use in my experiment, and I'm shuffling those. Meaning that for some subjects, the yellow words are going to be read aloud and the blue words will be read silently. For other subjects, it's the opposite. The blue words will be read aloud and the yellow words will be read silently. So counterbalancing or randomizing your stimuli are definitely things that you want to be doing in your experiments. And this is a very cheap way of having the computer do it for you. So rather than hard coding anything in, I'm setting up the variables. So each color has a name that will be used in the instructions, and then it has an actual hex code, which is the actual computer code that will define the color on the screen. And then we're shuffling those so that some subjects get it one way and some subjects get it the other. So as we'll see when we go through my experiment, color 0 is always the allowed color and color 1 is always the silent color, but that varies subject to subject. Is it blue or yellow? We don't know. The computer is going to randomize it for us. Anyway, the study instructions tell subjects how to run the study or how to behave in the study phase. And then we finally get to the good part, which is what happens to start the experiment up, to really get to the first loop, and that is set scene to study. So far we've been setting scenes to various instruction screens, and when set scene is told to switch scenes to an instruction screen, it just looks for the instruction screen, sets it up, scrolls to the top of the page, makes sure everything begins at the beginning. It's a very good place to start. And it's only for a couple of special cases that anything else happens. And one of those special cases is if we tell it to set the scene to study. So we're going to call the start study function. And this is going to actually make us loop through different study trials. In order to understand this function very quickly, let's look at how stimuli get loaded, and then we're going to come back to this function here, and we'll go through and have a better understanding of what's happening here. So yeah, where am I loading stimuli, by the way? I told you guys that load words PHP file is going to load in all the words. And in fact, before I even show you where I'm loading the stimuli in the JavaScript, let's actually go in here and look at the load words PHP file. So this script basically just opens up a CSV file. It opens it, it creates an output string that it's going to send back to the JavaScript. And what the JavaScript is expecting is one word per line. So it's expecting a big long string, and each line will just contain a single word, and that's basically all it's looking for. So we start this string as empty, our output string that we're going to send back to the JavaScript. And what we say is, while we're not at the end of our file, grab a new line, make sure to convert all the letters to lowercase just in case. Make sure to trim any white space or end of lines away from that line that we're grabbing. Then we have a little check to see if the very first character in our line is a comma, then that means that we do not have any item. So this will occur when you have an empty cell. And we also check to see if literally there's not even a comma, there's just nothing. So what we're basically doing here is saying, if you have grabbed an empty cell, if there's an empty cell in the CSV file, then don't don't proceed. However, if we have a cell that has some value, some letter or number in there, then what we do is this little bit of code here basically grabs the first cell. So again, you could have a CSV file with multiple columns, but this load words PHP file is only going to grab the words that come out of the first column. If you want to do more columns, you're going to have to modify this yourself. There's two ways to grab the first column, by the way. Here's a nice simple way if you have PHP 5 or above. But if you have an older version of PHP, this will work as well. This is just a little more cumbersome way of getting at the same thing, which is grabbing the first column. Once we have the first column, we check to see if output is not blank, meaning there's already a word in there. Then we first add a new line code, so we move to a new line, and then we add our item on. If this was the very first item, so if output was totally blank, then this would get skipped and we would just add the word directly. So that's all this part of the code is doing. Once we've looped through the entire file, we close the file, and then we send the output back to the JavaScript. And we've already seen this before. You know, when we send data back to the JavaScript receives it, and then it does something with it. That's what it did with the receiving the subject ID code. And that's what we're going to do with the output from load words. Okay, so if we want to know where we're loading stimuli, if you were paying attention up here, when we looked at where we were listing the file to log subjects, we also had a variable called getStimFile, and it was going to call load words. So if we look for getStimFile, we'll find it. It's at the bottom of our script. And it is not in a function, meaning it just gets called as soon as the experiment begins. So this will be called before your subject even clicks that begin button. And this is a bit of Jquery. It's a really fast way of sort of calling a PHP file and getting some information. So, you know, when we want to send data to PHP, we use our post function. This is how I would recommend getting information from PHP files. So you could load information from multiple stimuli files if you want. I will show you, though, that for consistency, I did set up a post data function originally, and that's what I was using to send data to my PHP files. I also started to set up a get data PHP file, and I can't remember how well this actually works, but you know, I left it here for sort of legacy purposes. It calls the data request, and the data request is set up basically to try and dynamically figure out if you're trying to post or get data. I would actually just recommend calling the Jquery get down here, but you know, it's up there. If you want to complete that part of the code, that's on you. So this Jquery function is very simple. It calls a PHP file, and when that PHP file sends it data, then it executes this function, which we're writing right here. So we're writing the function on the go. The data that we receive is going to go into a file called, or a variable called data. Very convenient. And you can see right here, we're basically taking that data and we're splitting it by the new line character, and that's going to give us our words. So words is an array of words that we got from calling loadwords.php. A lot of other stuff in this function here basically assigns and arranges our stimuli. And there's actually a ton of debug output here. So console.log is writing things to the console that we can see. And let me actually show you where you can find console.log if you want to take a look at it. Okay, so if you go to your experiment, and in Chrome, if you open up developer tools, you will see a whole bunch of information that is logged. And actually, I'm just going to reset the page. If you don't have this open, it sort of hides everything in these object names. But if you actually load the page with the developer tools open, it's much more readable, I find. So notice that what I'm basically doing in this sort of console is I'm outputting everything that I might want to know. So as I was developing this experiment and modifying it from Dr. Prestizo's original code, I changed quite a bit, and I wanted to kind of make sure that each step was working the way I had planned. So I am a debug output fiend, but I do it to make sure I know precisely what's happening at each step. So if you look here, the very first thing that we're outputting to the console is I'm listing the two colors, And the reason I'm doing this is because remember I shuffled the colors. So in this case, 0 is yellow and 1 is blue. If I reload the experiment here and I look at colors, now 0 is blue and 1 is yellow. I basically am outputting the colors to make sure that the shuffling is working correctly, and also because blue should be the allowed items, if I scroll down to where I've set up stimuli, I can see here's an allowed stimulus, and it is indeed colored blue, so the computer's getting the color correct. So I like to have a lot of debug outputs when I program, just so I can follow and make sure that all my stimuli are getting set up exactly as I need. Okay, next we split the data that we've received from load words into our words array, and then we output all of our words. And so we can see this is the output that we're getting from load words. It's just a big list of words, and we're getting 360 of them. That checks out. That's exactly what we would expect from our 360 word CSV file. Now, what you could do at this point if you wanted is just shuffle the words, and that would create a random order of the words for your experiment. I prefer not to shuffle the words because what I like to do when I'm logging my data is say that, on the first study trial, I showed word 13, and that means it's the 13th word from the original CSV file. Then I showed word 67, and that's the 67th word from the original CSV file, and so on. I like to know exactly what word I'm showing numerically, just so I can triple check for errors and make sure that everything is coming out correctly. If I shuffled the words, then I would no longer be able to track that because the first word would no longer correspond to the first word in the CSV file. So instead of shuffling the words, I create an order array, which is an array that just counts from 0 to 359. So it takes into account all 360 items in the words array. And then I shuffle that. And then if I want to refer to the first word of my randomized order, rather than referring to word 0, which will always be the first word from the CSV file, I can refer to word order 0. And that will give me perhaps word 67, perhaps word 102, perhaps word 340. I mean, you don't know because the order is now shuffled. So this is a way of randomizing my stimuli. And when I log my data, I can log the word, I can log the order, which tells me it's the 128th word. And then I can also log what trial I'm on. So maybe I'm on trial 0. And then when I go to trial 1, all these numbers go up by 1. So I can get the trial number, what word I got, numerically what word I got from my stimulus list, and then I can get the actual word itself. So that's how I like to do things. That's what's happening in the code. Change it if you don't like it, that's fine. So here's what I'm doing. After I've got the order, what I'm doing is logging all those numbers so you can see the order. So new word order. So the first word that in my stimulus list is now going to be the 296th word from my actual CSV file. And then the 245th and the 152nd and the 225th and so on. So you can see we have randomized the words without actually shuffling the word array itself. Next thing I'm doing here is I'm using some loops to basically assign different study types. So if you look back in the experimental parameters section, I mean, I had my blue and my yellow as my colors, but I also said that I'm going to have 2 different study types, so 2 different study kinds of trials. I'll have allowed and silent trials. Also notice I have a few other variables in here, like the number of study trials I want, the number of test trials. You can change all these things. So if this were a real experiment, I'd probably have numbers closer to this. But because this is a demo, I want to keep things nice and short for you guys. So I have 10 and 15. But once you know how many study trials you want in total and how many types you have, if you have 2 types and you have 10 trials, then 10 divided by 2 means that you're going to have 5 allowed and 5 silent trials if you space everything evenly. So I'm taking the number of study trials, I'm dividing it by the number of study types that I've got, and then I'm adding the study types kind, allowed or silent, to a new array that I'm creating. So what this array is eventually going to have is 15 entries, because I'm also going to add in all the test trials. The first 5 entries will say allowed, the next 5 entries will say silent, and the last 5 will say new. And so that's what all this code is doing. I'll leave you guys to further dissect it, but hopefully that explanation gives you enough information that you can kind of see what's going on here. So the reason that I'm creating these different types is that when I create my stimulus list, I don't just need words, I need to know is a word a loud word or a silent word. And so this is where I take the words that I've randomly ordered and I combine them with the word types, or W type. So for each item in my list, going through both the study and the test, if the word type is allowed, as I've just assigned up here, then the study color for that item is going to be the first color. Maybe it's blue, maybe it's yellow. If it's silent, the study color will be the other color. And if it's new, the study color will be none. If we identify a W type that isn't one of these three, then it's an unknown. And there shouldn't be. But this is, I like to include little error catching sections of your code just in case, something happens that you didn't anticipate. At least it won't be classified as a none, and then you'll be very confused. It'll be classified as something different, and then you'll be able to go back and hopefully find your bug. Anyway, once we have all that information, I create a stimulus. A stimulus is firstly identified by where it came from in the original CSV file, then by the actual word. So here, again, words order I, rather than words I, to identify the word from the correct randomized order. Then we have the type that stimulus is, and then its color. And I'm outputting this to my console. So here's my master stimulus list, and you can see this is what's being produced. The word south was the 296th word. Again, that will be the first word that I'm pulling out of my new random order. It's an allowed item, and its color is going to be blue. And if I look up at my colors, color 0 should be blue. And it is. So everything's working correctly so far. So notice the first 5 items here are all blue. The next 5 are yellow. And the next 5 are new items, or items that have no color. I have now created a stimulus list, a master stimulus list, where I have randomized the words, I've randomized the colors and everything. But now the items are all in order. And so I need 2 final things. For the study phase, I only want to show the first 10 words, and I don't want them to come all the blue words followed by all the yellow words. I want them to be randomized. So I'm going to create a study order that says from your stimulus list, the first item to show will be the 5th item. So 0, 1, 2, 3, 4, 5. So court will be the first item that we show, followed by the 7th item. So then grade, followed by the 8th, which is damage, followed by the 0th, which is first up here. The south. So if I look, court, grade, damage, south, this is the study stims that I'm outputting here. And similarly for the test stimuli, I want to include all 15 items. So now I have a list from 0 to 14. I randomize that, and this is telling me which stimuli I should grab for the test. And by doing this, I now have a stimulus list, and I know the first 5 items are blue, the next 5 are yellow, the last 5 are new or no colored. And I have separately randomly ordered that list for a study phase and an eventual test phase. And so going back to my code, that you can see the remaining part of this section is basically just creating some new order lists. So rather than an order list for the words themselves, we have an order list for our study order. And we have an order list for our test order. And then the rest is just debug code that's outputting that to the console so that we can verify we've done things correctly. So that's pretty much all we have in our stimulus setup part of the experiment. There's a lot of manipulating of lists and orders and so on, but if you spend a little time with this, I think eventually it will come to make a lot of sense, and I don't think as daunting as it might seem if you looked at this without watching this video here today. Okay, so we called the scene, set scene, study. Before we look at the start study function, we've now figured out where our stimuli come from. And so we're going to have a stims variable. And if we want to grab the study items, we can grab a stim item from the study order of 0 through 9. And if we want to grab a test item, we can grab a stim item from test order 0 through 14. And that will have all the items that are in our experiment right now, and they will be in a unique random order for the study and the test phase. So you can get a hint this start study function is going to somehow be adding those stimuli onto the screen. But before we take a look at that, really quickly, if we scroll up, where's the study text variable that's actually setting up the screen? It's right here. It's very short. It's basically one container that centers things horizontally and vertically. HV center is a CSS tag that is set up in the experiment.css file, and that will center things horizontally and vertically. If you see an H center, that only centers things horizontally. So HV is horizontal and vertical. H center is just horizontal. We have this class called stim1. And other than that, there's really nothing to it. I mean, we mess with the font size, but that's about it. So we make the words nice and big. So the start study function is going to have to do something with putting our stims into stim1 here. So let's see how we do that. Okay, we're looking for start study, and it is the first function down here in the study phase. Start study has a variable that tracks what our current study trial is. So currently we're on trial -1, meaning we have not started the experiment. Other than that, it just calls a function called next study trial. Next study trial is the function that will always set up the next trial and set up everything that's needed to show it to the screen. So the first thing it does is it increments the current study trial number. So we go from -1, we end up at 0. So now this number is what we're going to use to refer to what position in the study order we're at. So study order 0 will be our first stimulus that we end up showing to the screen. We check to make sure that the current trial number isn't past the number of trials that should be in the study phase. If we are at the end of our study phase, we end the study. We end the study phase and we move on to the next phase. Otherwise, we use some Jquery code to find that stim1 tag, and we clear it. And then what we do is we set some timeout functions to make the stimulus appear. So in my experiments, we have a 500 millisecond blank between each study item in a study phase. So what we're doing here in this next study trial is we're first blanking out whatever stimulus happens to be on the screen, and then we're saying in 500 milliseconds, that's what this variable is equal to, duration blank. If I scroll up here, duration blank is 500, meaning we'll have a 500 millisecond blank before and after stimuli, and we'll show stimuli for 2000 milliseconds or 2 seconds. So the screen is blank, and we say in 500 milliseconds, show the study trial. And then after 500 milliseconds and 2000 milliseconds have passed, so 2500 milliseconds from now, end the study trial. And that's all that happens. So show the study trial and then end the study trial. The reason we don't just put duration study here is, think about it. Starting from now, we're going to have a 500 millisecond blank. Oh, and I noticed a typo here. There should be 2000. If 2000 milliseconds after right now, we ended the study trial, then that means there'd be a 500 millisecond blank, and the stimulus would only be on the screen for 1500 milliseconds. So we actually have to add the blank duration onto our timeout here to make sure that the study trial ends at the appropriate time. So show study trial is going to show our stimulus, end study trial is going to end everything. So show study trial. First of all, we're going to set up a study color, so a color to show our stimulus in. We're going to assign a default color of red, because basically if we encounter a stimulus of a type we don't recognize, we'll have it appear as red, and that will be a sign to us, the programmer, that we have something weird going on with the stimulus types. But what we're doing here is we're going to access our stimuli. And remember, our stimuli are all in order. Right? Here's our stimuli. The first 5 items are blue. The next 5 items are yellow. The next 5 items are totally new. We're on trial 1. Rather than simply grabbing stimulus, stims, and study, rather than simply grabbing the first stimulus, which would always be an allowed item, and then the first 5 items would be allowed items if we use this code, we're grabbing the stimulus from the study order, the first study order. And remember, that means we're going to grab the 5th item on trial 1, the 7th item and 8th item on trials 2 and 3 respectively. Then we'll go to the 0th item and so on. So the reason that it's not just stims and study is because we want to make sure we're using that randomized study order. What we're doing here is we're checking what type of stimulus do we have here. Is it an allowed item or a silent item? If it's allowed, then our color is going to be the hex code for our first color, and if it's silent, it'll be the hex code for the second color. And then we use a bit of Jquery to basically just insert the word in uppercase into our stimulus. If we didn't want to color the item, we could cut out this extra stuff. We could cut out this extra span. And we could basically just assign stim1 to have the text value of the word that we want to show. However, we do want this extra stuff. What this extra code is doing is just setting up a little container that will set the color of the word to be the appropriate color. And that's it. All show study trial does is figure out what color should we show the stimulus in, and then show the word with a container that has the right color. That's all that's happening. So that gets called after the blank has ended. And it stays on the screen for another 2,000 milliseconds. And then when that time is up, then we have the end study trial function that gets called. So that's this function here. All this function does is it logs what just happened to the data file. So this function log trial here is going to take what phase of the experiment you're in, what study trial you're on, what stimulus you showed, and any other information you want to log. So this is just a string you can pass. If you build up this string and you separate it with commas, you can basically add multiple new variables that you're logging at the very end of your data stream. And if we go and we take a quick look at log trial here. So here's log trial. There's a bit of explanation of what's going on here. But ultimately, it just posts data to the data logging file. And what it does here is it automatically adds the subject ID code on. It adds in that block name, so like the study phase, it adds in the trial number. It loops through all the properties of the stimulus that you showed, and it saves every single one of them. It logs your reaction time and response time if there is any information there. And that's it. So if you remember when I did show you my tables of some old data that I had been logging, here's the subject ID code, here's the phase of the experiment we were in, here's the trial number, here's the stimulus number from the stimulus sheet, here's the stimulus that was actually shown, here's the kind of trial that we had, here's how long the blank was, and here's how long the study duration was. You see this is old data because these numbers have changed. But nonetheless, this is just comma-separated data, and it was all built here in the log trial function. It assembled a string of all the important variables separated by commas, and it sent them to the log data file. And if we scroll up to the top, we can see the log data file is logdata.php. And looking at logdata.php, it looks identical to log subject that we saw already, except that rather than a subject ID that we're logging, it's data. And so we have no data by default. We're logging things to the data table instead of the subject table. And we don't return anything. We don't need to return a subject ID like we did with when we tried to log the subject. Other than that, it's identical. So it's very basic code for inserting things into a Postgres database. Okay, so after the study trial has logged all that information, then we move on to the next study trial. So next study trial is what we called to start the study trial. And if we go up, next study trial is now going to continue. So now we'll increment the current study item by 1. So now we're on the next study trial, and everything proceeds as it just did. So this is basically just a loop. Next study trial, to show study trial, to end study trial, back to next study trial. And once we get to the end of the list, then we have an exit function called end study. And all end study does is it clears the stimulus on the screen, and it sets the scene 500 milliseconds from now to the study end scene. So we are back to setting the scene to something new. The reason for this blank is so that after the last stimulus has been shown, you don't just immediately get hit in the face with an instruction screen. You have one more blank before you get to the study phase over screen. So that's why we clear the stimulus, and we don't just immediately call set scene. We have a short blank, a 500 millisecond blank in this case, for study end. You should be getting the hang of things by now, though. If we scroll up into our text area, we'll find study end. It's just an instruction screen with a button that sends subjects to test instructions. They click on that, they end up in test instructions, which is just another instruction screen. When they click on that, they get sent to the test. The test is a little more advanced than the study screen, but not by much. It basically is just a centered area where we still have stim1. This is where we'll be showing the test word. And this time we have a little scale below. We have two buttons, and these buttons will say old and new. And when the subject clicks on the old button, we call a test function called test response and pass along the old response. And if they click on the new button, that calls a function called test response and passes on the new function. So we'll take a look at that in a moment. But other than that, it's very similar to the study phase. It just doesn't go by automatically. So when we set the scene to the test phase, we call start test. Start test is going to look very similar to start study. We set the current test item to -1. We call next test trial. On next test trial, we increment the test trial number. We check to make sure we're not at the end of the test. If so, we end the test. And I'll show you that right now. We end the test. We basically just clear the stimulus. We hide the scale. And we wait for 500 milliseconds. And then we show the test end screen. So that will be the ending, thank you for participating, basically, part of the experiment. We'll get to that in a moment, though. So assuming that we're somewhere in our list, we're not at the very end. We, first of all, clear the stimulus. We also hide the scale so that subjects can't see the old and new buttons. And then what we do is we set up a 500 millisecond blank. So 500 milliseconds from now, call the show test trial function. Now notice here we don't set up another section to call the next test trial function, or we don't set up another section to move the test trial on, because test trials are subject-paced. So once the test trial is up there, we're waiting for a subject response before we do anything else. So it's actually even a little simpler to set up and start the test trial. So show test trial, what we do here is pretty similar to what we were doing before. We're going to show the stimulus. Notice that this time it's going to be in white, so we don't even need to have any code to check which color it was studied in. All test items are shown in white, so it's a little simpler even. But now we're referring to the test order stimulus of the current test trial. We set up here, so the stimulus is going to appear right away, and 500 milliseconds later, we allow the scale to show up. This is just a little flourish, the way we do things in my lab. So to show you what that would look like, after a subject clicks a button, the word appears, and then the scale appears. And it just seems to flow a little better. It keeps the focus on the stimulus rather than the buttons appearing immediately. It forces the subjects to think a little bit about their response before they click, because they can't click right away. But if you don't want that, you don't have to keep it in the script. You could get rid of this set timeout and just immediately have this in your script, and then the scale would show up immediately. I'm going to leave the delay in, however. So we're showing the stimulus. 500 milliseconds later, the scale appears. The only other thing that show test trial is doing is it's getting a start time. And this is basically going to be used for reaction time logging. Other than that, remember that once the test trial appears on the screen, the computer will stop and it will just wait. There's no other way to proceed in the experiment unless the old or new button is pressed. When the old button is pressed, we call test response and we send an old response. And when the new button is pressed, we call the same function, but we send a new response. So test response is how we're going to get out of the test trial. And here's the test response function. It takes a single variable, which is what response was made. And it basically calculates, or basically gets the end time, so the current time that it is right now when the button was pressed. And it compares that to the start time, and it calculates out your response time. Once it has that, it has your response time, it knows what response you made, and so it can go ahead and log a trial. So we're going to log, this time rather than study, we're putting test to indicate we're in the test phase. We indicate what test trial we're on, we indicate what stimulus that corresponds to, and then rather than logging the duration of the blank plus the duration of the study time, we're logging the duration of the blank plus the response time. So we're kind of lining up our study and test phases so that after the stimulus information, the last bit of stimulus information has been logged in the CSV file, the next column will deal with how long the blank was between trials, and then what the reaction time was. And in the study phase, because the trials go by automatically, this is a constant value, but in the test, this will change depending on subject responses. And then we're also logging what the subject's actual response was. Then After everything is logged, we call the next test trial. And this process repeats. We loop through, we set up another test trial, we show it, we wait until there's a response, and then we go ahead and calculate the reaction times and log all that to the data file. When we reach the very end of our test, as I already showed you, we hide everything, we set up a brief blank, and then we go to the test end screen. The test end screen basically says, thanks for finishing the test. There's one more thing, there's a little quiz. And as I already showed you guys, there is a quiz at the end where we ask participants, which color were they reading aloud? Did they make any mistakes? Is there anything else they'd like to let us know? Much like the consent form, here we try and save their quiz, but if we detect any errors, we don't proceed. We throw up an error message and tell them to fix their errors. But if we are able to save their study data, then we move on to the debriefing form, and then that's the end of the experiment. Taking a quick look at this one final function then, so how do we save their quiz? So here's our save study quiz function. We clear our errors, we clear any highlights. So in this quiz, if you make an error, it will actually highlight the section where you've made an error and tell you to fix it. We'll highlight it in red. Again, you know, if you're not savvy enough with HTML or JavaScript to know exactly how this error highlighting and so on works, I'll leave it to you guys to figure that out. But suffice to say, it does a few checks to make sure that everything is valid. And if everything is valid, then it goes ahead and grabs the responses from the various questions and puts them into an array. And it passes that on to the log survey function, which is the last data logging function that we've got. This log survey function, by the way, uses the same data saving function that saving a trial does. So rather than having the study or the test phase, we're actually going to list this as coming from the study quiz. So it's a third kind of phase that will appear in our data file. And the responses are eventually going to get pushed together into a comma-separated string. So first we'll have the allowed color subjects said that they were reading aloud, the number of misses they had, so allowed items they forgot to say aloud, and they sort of missed in the list, number of silent items they accidentally read aloud, and then anything else that they happen to have said. This function here is a little sophisticated. It's basically just trying to make sure that things end up in quotation marks so that the CSVs don't count any commas that subjects might type as separate columns in the CSV files. So this information is all put into resps, and if we go up to log survey, we will find all it does is take that information, add the subject's ID, adds the survey name. So again, this is like our block name. So instead of study or test, now we'll have study quiz. And it pushes all the responses together into one line, one text string separated by commas. And it sends that to the same data file that we were logging our actual trial data to. So in that one data file, we're going to have everything that we need to analyze how subjects did in our experiment. Okay, and that is basically it for the JavaScript. There's just a few final things I wanted to show you guys. All that console debugging information only appears if you set local or server debugs to be on. So if you have server debugs on, when you try and log data to the servers, you'll actually see little messages appear in the console. So you can have your developer tools open as the experiment runs, and you can watch what the experiment is trying to do with the server. Local debug is when the script is doing something locally, so like randomizing stimuli lists or doing any of the various checks that it performs throughout the experiment. I like to leave, I do leave these on when I am working on the experiment, but when it's ready to go live and subjects are ready to use it, I usually turn these off just so they can't see the error messages as clearly. Not that anyone would ever look, but who knows? One other thing that I didn't show you that's commented out here is an extra line. And this is just to show you that you can add in, if you want, extra buttons onto different screens if you want to have a quick way of jumping around in your own experiment. So this little code is actually adding on, it's appending onto the end of the welcome screen, a few extra buttons. So actually, if I uncomment this line, and then I re-upload my experiment, then when I go to my welcome screen, I'll find some extra buttons. So if I want, I can jump right to the memory quiz. And I can show you guys, by the way, those errors. So if I type in a word that was not blue or yellow, I'll get, this will not only be highlighted red, but I'll get a little error message down here. So that was all in the save survey function. It was doing all these checks. It was highlighting things. Whoops, that is not spelled correctly. Highlighting things that I did wrong. See, now blue is an acceptable response. It may not be the right response, but it's acceptable at least because it's blue or yellow. But now I forgot to fill this in. And you can see the various errors, but if I fill them all in correctly, then things proceed as they should. Yeah, if you want, you can add in extra buttons wherever you want. And I do this during testing, so I don't have to sit through the study phase all the time. But do remember to set these flags to false if you don't want your subject seeing the output of your experiment, the debug output in the console. I don't think it really makes a difference. No subject's going to go looking for it, but who knows? The only other thing I wanted to show you are these two other files here called txt subject and txt data. So if you are not able to set up an SQL database or a Postgres database, I should say, by the way, all my code is set up to be Postgres compatible. If you use something like MySQL, you're going to have to modify my code over to MySQL function. So what is txt subject and txt data? These are versions of the logging files that do not require a Postgres database. So this is a less secure way of logging your data. You're just going to log data to a text file. Any subject who knows where they can find that text file could go and see a list of everyone who's participated, could go and look at your data. I do not recommend this technique, but you know, if you do feel like security through obscurity is fine with you, because most subjects are not going to know where to look to find your text files. Most subjects are not going to go looking for them. But in theory, your data would be out there for anyone to find. So this is, I would say, use at your own discretion. Use your own best judgment for whether you want to take this approach. And I take no responsibility for if anything happens from using this approach. But if you do not want to use a Postgres database, there is another way to have PHP log your data, which is to just save it to text files. So this script is identical to the log subject PHP file, only instead of using Postgres, we're actually just opening a text file. It will still be subjects underscore and then your experiment ID. It'll just be .txt. Now, if you do want to go this route, there's one other thing you have to set up in your experimental folder. So the JS experiment demo that I've given you does not have a text folder. You actually need to create this directory, create this folder. So you would just call this folder txt, and you would have to give write permissions. I believe it's sufficient, at least for me, to set up owner and group with write permissions. You might even have to go to other if you find that it's not working. But once there's a folder called txt, right now it's empty. If I were to change my experimental JS file to use txt subject instead of log subject and txt data instead of log data, then what would happen is I would see text files here that would start to log my subject information and my CSV trial outputs from the trials. Where you would actually change that in your script is up in the parameters section. So rather than using log subject, you would use txt, and rather than using log data, you use txt. You make those two changes. It's very easy to log this stuff to text files. Again, I do not recommend that technique, but if you do want to pursue it, and you understand the risks, go ahead. It's an option. So the text folder does not exist because I want to discourage people from using that. But hey, if you need to use it, you need to use it. One last thing that we haven't looked at is the view subjects. If you look at the view subjects HTML file, you'll see it's a very basic form that ultimately calls viewSubjects.php, and it basically just asks for a password. And so you can see that here. Now, if you come here and you try and log in with a password and you don't know the password, you're going to get an access denied. So what is the password and what does this do? Well, if you look at the viewSubjects.php file, you will see that basically what this does is it receives a password from a form. It checks to see if that password is equal to secret with 3 exclamation points, Please change this if you're going to use this script, but that's the default password that you've got there. And then what it does, it gets the subject list from your Postgres database and it displays it so that your research assistants or you can easily see who's participated. If you use the text files instead, you can just go and directly open the text file and see who's participated, so you don't need this option. However, if you are using the Postgres database like I recommend, you're going to need this option in order to very quickly, without having to go log into your database, see who's participated. So if we give this a shot, secret with 3 exclamation points, because nobody would guess that, you can see you will get a nice list of all the different subjects that have participated in your study. So that's basically it. So in the description down below, you can download a zip file containing all of these files, and you can go ahead and start modifying this to create your own experiments. Again, the only condition I've got is please leave my colleague, Matt Pastizzo, and my name on the files if you want to add a new line, further modified by, or currently run by or authored by. Go ahead. You can add whatever names you want, but just please leave our original credits to recognize the hard work that was done by both of us to get the script into this format. And other than that, good luck in running your own studies online. And thanks for checking this out today. All right, until next time, guys. See ya.